So now let's discuss about the types of wave. Now that we have a basic idea, waves can be broadly classified into transverse wave and longitudinal wave. Now, if you observe the definition that is given to us in your books in different net, you will find that transverse wave is defined as the waves. The displacement of the medium is perpendicular to the direction of propagation of the wave. For this type of waves, they say that the displacement of the medium. Say, suppose this is your medium, this is your medium. So, if the wave is going in this way, say, suppose the wave is going in this particular way. Let me draw axis. So the particle will oscillate perpendicularly. So this is what transverse wave mean. Now, as I've said, if you in my previous example, this is a pond. If I throw a stone over here, the wave goes in this way. If you observe, the wave goes in this way. So the direction is over here. And if you look at the material, the material goes something like this. So this material will go up, then come down. That is, this part will keep on doing this. So that it is oscillating perpendicular. So this is its direction of oscillation. I'll write this with different color. Direction of oscillation. Oscillate means to move to and fro. And how is the wave going? How do we see the disturbance? It's going in this way. One wave will come and it will take this. So it's going in this particular direction. So direction of oscillation is over here, and direction of movement or transfer of energy is going from here to from west to east. So we see that this is the direction and this is the oscillation. This is perpendicular. This is 90 degrees. So this type of waves can be categorized into transverse wave. This is how we define transverse wave. Now let's discuss about longitudinal wave. Now the definition of longitudinal wave is the longitudinal wave, the displacement occurs parallel, the displacement of the medium. Please mention the displacement of the medium. The displacement of the medium occurs parallel to the direction of the wave, or the energy transfer. So what does this definition mean? Now the best way to define this is to take the example of a spring. So this is a spring. Now what we do is we compress this spring, we compress this part and we release it. So what we see is that first this particular compression will come over here. Then while this compression goes over here, this is elongated. Now after this is elongated, again this spring will again come back to its original position, and this part will get elongated and this part will get compressed, and similarly this will follow. Now after this part gets, a part which is behind this will now be elongated, and so this part will again be compressed. This part will be normal, this part will be elongated, this part will again be normal, and this part will be compressed. So in this way, first a compression will occur, first over here a compression will occur, then it will come back to its original position, then it will be elongated, then again it will come back to its original position. This is original, and then again it will be compressed, again it will come back to its normal position, again it will be elongated. So now you see, this is the process. Now try doing this with a spring and try just observing the material. Just observe the material. You don't have to look at how the spring is traveling. Just take one part, and observe. If you give a slight disturbance, first if you stretch it, it will stretch, then it will come back to its original position, then it will compress, and again it will stretch, then to its original position, then it will again be elongated. And you will see, this is how a spring transfers energy. Say suppose this is a big spring. So at this point I make the compression. At this point I make the compression or elongation and just release it. I'll see how in the whole of the spring, there is this compression, expansion, and this is how the wave is traveling. So now you can see that the medium is disturbed in the direction at which the wave is traveling. So now we have, there is a disturbance. The disturbance is in this particular direction. This is a direction. This is a disturbance. Again it goes, again it comes. And if we observe the traveling of the wave, we will see that the wave is also traveling in this particular direction. So what we can conclude is that the direction of the propagation of the material or the medium is parallel, that is in the same direction to the direction of the propagation of the wave, and therefore this type of waves is known as longitudinal waves.